I would actually burn myself because the body reacts to extreme cold the same way it does to extreme heat. Well, dry ice is interesting. It sublimes. It goes directly from a solid to a vapor, and we're illustrating that with these tall graduate cylinders we have at each end of the lecture tables. Before the show started, we just put a little bit of a soap solution in each of these and added vegetable dye to that to get a nice color. As you'll find out as the shows go along, I like messes, and actually inside each one of those soap bubbles, it's trapped a little bit of a fog or a cloud. We'll talk about that more a little bit later. In the meantime, we have two students here who are very brave, and I'm giving them a little bit of a soap bubble hat there. Thank you. So let's come back to the middle and look at some more
Told you you'd get picked on if you went over there.
Dioxide.
That's
Carbon
it.
dioxide gas is heavier than air. It's also colorless. You may have noticed that when I started this demonstration, I put a few pieces of dry ice into this beaker. Well, if I wanted to find out where the dry ice and the carbon dioxide in the beaker is, I can do a chemical test. I'll put this burning splint down into the beaker, and it goes out at the very top of the beaker. So even though I can't see the carbon dioxide, I know that this beaker is full of carbon dioxide. Well, that's a wonderful property. Carbon dioxide, things don't burn in it, or maybe there are some things that might burn in it. I have in my hand here at the end of these tongs a piece of magnesium. Magnesium is actually more chemically reactive than carbon, and it will literally burn in the carbon dioxide. It pulls away the oxygen from the carbon, forming magnesium oxide, and then there'll be little bits of carbon that you can actually see in the bottom of the beaker. Well, let's continue. I have here an Erlenmeyer, excuse me, an Erlenmeyer flask that has some water in it. I'm going to add a few pieces of dry ice to that if I have some that are small enough, and if they're not small enough, I can make them small enough momentarily so we can get those small pieces of dry ice down into that flask. Well, what's happening here? The dry ice sublimes, it bubbles up through the water. Remember, that's very, very cold. So what it is doing is it's freezing the water in the air. We're getting that water condensed, and we've actually formed the kind of artificial cloud or mist or fog. These are used in magic shows, stage shows, horror shows, things like that. I've occasionally wondered what might happen if I drank some of this stuff, and feeling very brave this morning, I'll do that for you. Here we go. Well, returning more or less back to normal, carbon dioxide is heavier than air. I'm going to pour it onto that candle flame, and we'll see if that puts out the candle flames. It does. Well, that's a wonderful property of carbon dioxide. So you can actually buy fire extinguishers that contain carbon dioxide. Well, one of the ways that you make dry ice is to have the carbon dioxide under high pressure, let it expand very, very rapidly. When it does so, it forms little bits of dry ice in the air. And that can condenses some of the water vapor in the air. So what we're going to do now is make some snow. And you can see that there are little bits of snow that come down there. Well, we can do this demonstration in a more interesting way if we have, say, 2 students who are wearing black pants and maybe one teacher who is brave enough to
He's over 52, sir.
Yeah, okay. You have a teacher?
Aim it in the zero direction.
Okay.
Now, if you will all turn around, face the front of the lecture hall, walk up to the table, that's it. Hold your arms out all the way in front of you. Do not turn around until I tell you. And are you ready now? Okay, here we go. That's our little demonstration we called
I'm kind of glad I didn't do
not
that.
sit down, keep working. Thank you for coming up. Thank you. Thank you.
Yes, very.
Fundamental lesson about chemistry that we want to produce today or present today is that chemicals and chemistry is everywhere.